All right, AP Calculus. So this video is going to look at our theorems that we're looking in chapter 1 with IVT and EVT. So intermediate value theorem and extreme value theorem. So what we're going to look at is what are the conditions in order to use those theorems, what are those theorems really useful for, and how in general we want to be using theorems throughout this course. So we're just going to go ahead and look at the whiteboard, and I'm going to go ahead and start to list those things out here. So first, let's start with IVT. So intermediate value theorem is the following. So let me go ahead and get on here. All right, so our intermediate value theorem. Now, one thing again about the theorems is we can reference them using this shorthand way. And you're going to see there's going to be a bunch of theorems in calculus that are going to be doing this whole VT. So there'll be IVT, EVT, and we'll get into mean value theorem, MVT. So very important that you can state the theorems either way. If you find it confusing to just be using the shorthand, feel free to, obviously you can write out, you can write out the whole, sorry about that, you can write out the whole name of the theorem. So in intermediate value theorem, we have to have the following conditions met. So, let me actually list that here. So I'm going to say conditions for use. So we need to meet the following conditions. One, our function, f of x, must be continuous. And, oh sorry, not and, but just must be continuous on some closed interval a to b. Second condition is that f of a must not equal f of b. Those are our two conditions that we must meet. So one thing to point out is where we are looking at our function, it must be continuous. Can it be discontinuous outside of that interval? Sure. As long as it's continuous inside our interval, then we're fine, we meet the conditions. Now, once those conditions are met, what does the theorem guarantee? So, and that's really what these theorems are. They are guarantees. They're existence, what I like to call existence theorems. It's not going to tell us what the answer is. It's not going to tell us where to find it. It's just going to tell us, does an answer exist? And that's the power behind these theorems. So for this one, it guarantees that for some value d, which is between, well, actually, let me not write it that way, because we don't know if a is bigger than b. For some value d between f of a and f of b, there must exist at least one c between a and b where f of c equals d. All right, so that's a mouthful. Okay, and that's a lot to kind of process verbiage wise. So what does that mean? So sometimes it's better to see it as a visual. So best way to do this is whenever you can draw a picture of the situation, do so. So I always start with, again, we have to meet the conditions. So let's imagine drawing a continuous function from a to b. So I'm going to put some axes here. So here's A, here's B. And I'm going to just draw some continuous function. So let's say like so. So I can see, well, that was not a good color to use. Let me go back. There we go. So this is f of A, and then all the way over here, this is f of B. So we see we meet the conditions. F of x is continuous on this closed interval, yes. And f of A does not equal to f of B, yes. So that's what we have to meet condition-wise. All right, so now it says for any value, I can pick any value D that has to be between f of A and B. So let's say I pick here. Let's say this is D. The theorem says and guarantees there must exist at least one C between A and B where f of C equals that D. So where is this value? So if I, oops, and I didn't put that right where that should be. So let me fix that right now. So that's B. So now if I follow along, so we can see, oh yeah, here's the C value, so that this, yeah, f of C would be D. So that's what the theorem guarantees. That's all it's doing. Does it tell me what this C value is? No. Will I ever know what this C value is? Well, depends if we can have an equation that we can solve, if maybe this function is something that is solvable algebraically. But that's not the purpose of the theorem. The purpose of the theorem is to tell us if an answer does in fact exist. So that's all that this does. Now, the other thing I want to point out, it says at least one. There might be multiple values from A to B, which would give us the same answer. So let's say I'm going to change the shape of my continuous graph here. So let's say maybe we had a graph that does this. So keeping that same D value, now you see, oh, maybe it was here, maybe it was here, here, or even here. So now in that case, I would have multiple values. But again, all the theorem is going to tell you is, well, there's got to be at least one. If there's more than one, great. But there's got to be at least one. It's got to exist. So that's what our intermediate value theorem states. All right, let's scroll this down a little bit. And now let's look at the, oops. All right, so now let's look at the extreme value theorem. So extreme value theorem. So EVT. Not to be confused with EVOO or extra virgin olive oil. I hate that Rachel Ray came up with that so long ago. But anytime I hear EVT, that's what comes to mind. So pardon the aside there, but I just had to throw that out there. All right, so now let's talk about conditions for this. So conditions. So what are the conditions we have to meet for extreme value theorem? So you're going to see it's very much the same as IVT. We have to have f of x continuous on, again, some closed interval from A to B. And that's it. All we just need to do is just have a continuous function on a closed interval. If we have that, then what's the guarantee? So the guarantee by extreme value theorem is that there must be an absolute max and an absolute minimum on, in that interval from A to B for our function. So in short, there's got to be a highest point and there has to be a lowest point, hence the term absolute. So again, visually, what would that look like? So again, I'm going to set up. So here's A, here's B, and I'm just going to draw any random continuous line like so. So according to IVT, not IVT, according to EVT, there's got to be a highest point and there's got to be a lowest point. So I can just easily see from the graph, yep, this seems to be our highest point because I do start to curve down here. So this seems to be the highest point on the graph. This would be my absolute max. And do I have a lowest point on the graph? Yep, it seems to be this end point over here. This is my absolute minimum point on the graph. So that's all it guarantees. There's got to be at least a high point and a low point. Now, could there be places where there is more than one absolute max? So absolute max is talking about just like the value. So I'm going to say this is f of b. So let's say like, well, what if the peak went all the way up here? So let me like that. Well, still the absolute max value is this number. So when we say absolute max, we're not talking about the x values where it happens. We're talking about the actual y value, the coordinate. That's why we say absolute, meaning there's just one answer. Absolute minimum. There is a lowest value. Can that lowest value appear more than once on the graph? Yeah, there's could be multiple places where we keep getting this lowest value. But the value itself, there aren't multiple like lowest numbers. There has to be just the lowest value. So that's what extreme value theorem guarantees, is that we will have the existence of this highest point and this lowest point. All right, so one thing to caution, again, with the use of these theorems is these are, again, existence theorems. Now, a common thing that will happen is that when people use the theorems, let me minimize this so we can see both theorems. One thing to caution is that, well, what happens if the theorem fails? So what happens if I can't use IVT or EVT? So like you might be given a function and you're going through the conditions and you're like, oh wait, it's not continuous. Okay, so I can't use intermediate value theorem. So that means that there is no, let's say I'm trying to use IVT. Oh, it's not continuous. So that means there isn't a point in between. Wrong. If we cannot use the theorem, it does not mean that then we don't have a highest point or lowest point, or we don't have the ability to, find that value between the two endpoints. It just means we can't guarantee 100% that it exists. So the theorems, if we can use them, make it 100% certain. Yes, this is going to happen. If I can't use the theorems, can these conclusions still occur? Yeah. I'm just not 100% sure. I cannot guarantee that it's going to happen. So that's the thing I really want to caution you, because a lot of people initially when they use the theorems, it's kind of like they think it's like a light switch. Like if it's on, the light's on. If it's off, it's dark. No, if it's off, if we can't use the theorem, it doesn't necessarily mean that the room's going to be dark. Okay, meaning it doesn't necessarily mean that this can't still be happening. We just can't guarantee because we didn't meet the conditions. So that's our run through with these two theorems. And again, if you like these videos, if you found this to be useful, please hit the like button at the bottom, hit subscribe on the channel so you get updates of when new videos will come out, and I will then see you guys in the next video.